Alright, so this question is simply asking, what is going to be the net torque of this system once it's released from a horizontal position? Well, because we're not given any actual numbers here, we can only solve in terms of the other variables. So let's do just that. So the net torque, or really just the torque in general, as you know, is going to be equal to the force being applied perpendicularly times the lever arm, or the moment arm, or the distance from the radius, or the distance from the center of the rotation. So in this case, since just keep on with solving the variables here, we're only given m, so the force in both cases is going to be equal to mg times whatever the L is. Now, because we've got two levers, essentially, on each side of the central point here, these two forces are going to be acting against each other. But since both of these objects have the same mass, it's pretty safe to say that this side is going to be the one that's falling. So in order to calculate the total, like the net torque here, we're going to basically just add the torques together. But in this case, since they're acting against each other, one of these is going to be negative. So I'm going to label this L as 2 here, and I'm going to say that L1 here, the torque of L1, is going to be subtracted from this to make the net torque. So I'm going to say it's minus mg L1. And since this is really all we have to work with, but pretty much we can already say this is our answer, but just to simplify it a bit more, you can write it instead as just mg outside of a parentheses L2 minus L1, and there you go. This is our answer right here. This is what the net torque would be equal to, and be able to solve the number if we had more numbers, numbers given to us, but we don't, so this is the best we can do with this problem.